Today we are going to be solving the sum the targets problem, and in this problem you're going to write a function that takes in an array of integers of values and a target number, and you are going to return true if there's any combination of these values that sum to the target. So for example here 4 plus 5 equals 9, so you'd return true. If no combination of these sums to the target, then you'd return false. Does this example make sense? Good. So you're also going to have to do this in the complexity O of nt time, where n is the size of this array and t is your target value. And to get you guys started off on the right foot, I am going to tell you, you guys are going to want to do a dynamic programming bottom-up approach, where you are filling in this matrix of dimension n by t. And so I'm going to leave it up to you how you fill out this matrix, okay? So I'm going to give you guys about 5 minutes to do this, and I'll be around to help. All right, so this is what your matrix should look like about. And so to fill in a spot here, the question that you have to be asking is, can you make this target out of this subarray here? Okay? And if you can do that, you're going to put true, otherwise you're going to put false. So in dynamic programming, in order to compute a certain value, you have to use previous values. That's like the point of dynamic programming. You have to use these reoccurring problems. But in order to use previous parts of the matrix, you need to initialize stuff. So in DP, you're going to want to initialize something. So for this, we're going to initialize the first row. And the question that we're going to be answering is, can we make 0 out of 2, and the answer is yes, because we just don't use 2. 0 is always going to be true. And then all of them are going to be false except for 2, because we can make 2 using 2, right? And remember, you can't use 2 multiple times, so you can't make like 4 or any of these. So all of those are going to be false. Is that clear? Okay, so now we're going to move into the meat of the problem. So I'm going to fast forward to this spot here. And the question I'm going to ask is, can we make the value 2, the target value 2, out of this subarray, out of 2 and 4, any combination that sums to 2? And so one question you could ask is, can you make the target 2 without even using this new value 4? And so does anybody know where you can look for that to find out that question? Yeah.
We have to look up.
Right, yeah. You'd look right up, because here is answering the question, can you make the target value 2 without using the 4? And since it's true, that's also true, because adding the 4 in your array doesn't hurt it. You just don't use it. Are we all clear on that? So I'm going to just write that out generically as an important value to look at. So one important value is right above your current index. So if this matrix is DP, you can just look at I minus 1j. And if that's true, then you can be true also. All right, so now we're going to move on and fast forward to this spot here. And it's asking the question, can you make the target value 6 out of the subarrays 2 and 4? So last time we figured out a way to not use the new element and compute the target. Now we're going to see if this new element can help us make the target. So what we can think about to simulate using 4, we can say if we can make 6 using this 4, then we have to be able to make 2, the difference of 6 and 4, without using 4. So I'll repeat that again. The only way to make 6 using 4 is if we can make 2 without using 4. Why 2? Because 2 is the leftovers of 6 after we use 4. So this is not using 4, and this is 2, and it's true, so this gets to be true. Any questions on how we can figure this out using the 4, the new element? So I'm also going to write this out generically. So an important value to look at is dpi minus 1. So if you're like not having 4 in your array, and we're looking at the value j, so like 6, but 6 minus the value that we're using, 4. So it's going to be j minus vals, which is our array that I started off with, at I. Okay, so then basically we're going to fill out the rest of this chart by asking the questions, are either of these true? And if either of them are true, you're going to put true, else you're just going to put false. So is that clear? Is all this clear? Anybody have any questions or something I could explain a second time before class is over? Yeah? Yep.
So I'm just a little confused. How are we supposed to know to use the DP approach to this problem?
Right, so that's a complicated question, but mainly what I could say is that if you come up with an algorithm that you see you are computing the same subproblems, like for example here, to fill out both of these, we looked at this value twice, and we didn't recompute it, so it was nice that we could have it here. Yeah, you have a follow-up?
Yeah, so I guess, how are we supposed to recognize that we have multiple subproblems? I think that's where I'm getting confused.
Yeah, so that oftentimes that just comes with practice, and sometimes knowing when to use DP to solve a problem is just as hard as asking how do you just solve a problem, you know? But some clues that we might be able to use are that our time complexity is O of n t. So like, we obviously can't go through all the combinations here, but we have to, in order to cut the time complexity so much, you kind of have to like save values. So that's one thing to think of. Another thing you could think of kind of goes along with the practice idea. If you remember from lecture, you guys did a knapsack problem that was a DP problem, and it's kind of similar to this one. Like the target could be parallel to the capacity in the knapsack problem, and these values here can be like the weights, but instead of like making it less than the capacity, you have to get the capacity exactly. So honestly, just like practice is the main way, and you guys will get better at it as we go along in the class. Okay, cool.
All right, thank you.
Yeah, no problem. So if there's no more questions, class is dismissed. Have a good weekend.